Okay, so next chapter is related to thermal properties, right? Previously, we talk about some molecular model of the solid, liquid, and gas. And if we talk about thermal properties, okay, so if we talk about the thermal properties, so first property which is related to solid, that is known as thermal expansion. So thermal expansion means to expand the solid or to expand the material with the reference of or with the help of the thermal energy, that is the heating process, right? So first process is thermal expansion, or the first important property which is related to solid. Okay, so when we are talking about the expansion, so expansion can be easily happen in solid, liquid, and gas. So expansion can be done in all states of matter, either it is solid, liquid, or gas, right? And if we talk about the expansion in solids, so expansion in solids is very much less as compared to liquid and gas, because solids are tightly packed with each other, and the intermolecular forces between solids is very much strong as compared to liquid and gas. So that's why the expansion in solid is very much small as compared to liquid and gas. Is small in solid as compared to liquid and gas, and the temperature change for solid is greater, because we have to expand the solid material, so that's why we have to provide more amount of thermal energy. So that's why the temperature change for solid must be large as compared to liquid and gas. So these are some basic properties which is related to the solid expansion or expansion in solid. And if we talk about the particles in liquid, so particles of liquids are already further away from each other. So it means we require less change of temperature for liquid, and the intermolecular forces of liquid is very much low as compared to solid. So that's why liquid is very easily, or you can say that it is about 5 times more than solids in comparison of expansion, that they can easily expand or they can expand more than 5 times as compared to solid if we provide the same temperature or the same thermal energy to liquids, right?
Yes.
So if we talk about liquid, so liquid expands about 5 times more than solid because of weak intermolecular forces. And if we provide the same temperature, so the expansion in liquid will be 4 times or 5 times greater than the expansion in solid. And if we compare it with gaseous, and if we consider the gaseous state, so in gaseous state, we know that the intermolecular forces are very much weak as compared to liquid. So it means the gas can easily expand, or if we compare the ratio, so in ratio, we can say that gas expands about 20 times more than liquid. So liquid is already 5 times greater than solid, and gas is more than 20 times greater than liquid. So it means you can easily compare their properties, that how easily gas can expand as compared to solid and liquid, right? So these are some properties which is basic properties related to thermal expansion. And if we talk about the expansion, so normally when we are talking about the railway tracks, so if we consider the example of track, so in railway track, you observe that there is a difference between each part or each metal rod. So why we kept distance between the metal rods over there in railway track? If we talk about the example, and in example first, if we talk about the railway tracks, so there is a gap between. So let's suppose if we are working with railway tracks, so normally we observe that if we have multiple railway tracks so connected with each other, so there is a gap between consecutive rods of that metal rods which are connected for the railway track. So why there is a difference between these metal rods in railway track? So there is a difference, or there is a gap between this railway track. So why we are using this gap between railway tracks? So the reason is that let's suppose when train moves over this railway track, so you know that the tires or the wheels of that uh, train is made up of steel or iron. So that is also a solid material, right? And that is also a type of metal. And these railway tracks are also made up of metals, right? So both are conductor, both are metal. It means they can easily conduct heat and electricity, right? And when train passes over this railway track, so due to friction, the temperature of this railway track and the temperature of the wheel of the train will also increase, right? So when we are going to heat up the solid, so we know that when we provide some thermal energy to solid, liquid or gas, so they can expand easily. So that's why we use a little gap between these railway tracks, because in a summer season, when train passes over that railway track, so there will be already a high temperature in the atmosphere. And due to that high temperature, when train passes over that railway track, so there will be a greater thermal expansion in summer season. So that's why we kept gap between these railway tracks, right? So because of friction and the high temperature of the atmosphere, railway tracks will expand. So this is the reason why we kept distance between, or why we kept gap between railway tracks. So this is the reason, because of thermal expansion, we kept some gap over there. So that's why during summer season or during expansion, they do not overlap each other, right?
Okay.
Any confusion?
No, it's clear.
Okay. So this is a common example which we observe in our daily life, that is of railway track. And further, if we talk about, so there are some other examples, that is bimetallic strip, thermostat. So let's consider an other example which is related to bimetallic strip. So basically, when we are talking about bimetallic strip, so you know that the word bi means two. So it means we are going to work with two metal strips. So let's suppose if we are working with two metal strips of same length, but made up of different material. So we are working with metal of two different material, but of same length, right? Let's suppose if we consider the example of copper and iron. So one rod is, or one strip is made up of copper, and the second one is made up of iron. Okay.
Yes.
And these two rods are combined together just like this. If we consider these two rods, so let's suppose one is copper and the second one is iron. Okay, so now we have two types of rods, copper on the upper side, iron on the lower side. Sequence is not important. You may join them just by any sequence, and they are joined with each other, so they cannot move, or so they are combined with each other. Okay, so now we have a combination of two different metal but of same length. One is of copper and second one is of iron. So let's suppose when we try to heat, and when we start heating these bimetallic strips, because now we have two strips, so that's why we are using bi word, and two metals are there, so bimetallic strip. So when we try to heating, or when we try to provide the thermal energy to this bimetallic strip, so what will happen? Copper will expand, iron will expand, right?
Yes.
So now initially we have a sequence before heating. So before heating, they are in a uniform length in a horizontal line. So they are in a uniform structure before heating. But when we try to heat up these copper and iron or this bimetallic strip, so what happens? That copper will expand more as compared to the iron, right?
Yes.
Because copper is a good conductor as compared to iron. So copper expands more as compared to the iron metal. So when copper expands more than iron, so what will happen? This bimetallic strip will bend with copper outside, right? Like this. Now we have final structure of this copper like this, and same goes for the iron. Iron is also along with the copper, right? So this is the effect after the heating, because they start expanding. So during expansion, copper is expanding more as compared to the iron. So that's why this bimetallic strip will expand or bend in this way, because copper is a good conductor as compared to iron. So that's why these bimetallic strip will bend in this fashion, right? Any confusion?
Okay. No, it's clear.
Okay. And if iron, let's suppose if we are placing copper below the iron, so it will bend in a U-shaped type, because now copper is expanding more. So which, whatever we are metal using over there, so which metal expands more as compared to the other. So rod will bend from the direction of that metal which is expanding more as compared to the other, right? And if we talk about the applications, that why and how we use these metal strip or this expansion phenomena in our daily life. So we may use in fire alarm system, right? We use these bimetallic strip and this expansion phenomena in fire alarm setup. Let's suppose if we just consider the diagram of fire alarm setup, that how fire alarm will work. So just for explanation, let's suppose we have electric bell over here, and we have a hammer with it to strike the electric bell, and the whole setup of electric bell is enclosed in a box over here, let's suppose like this. Okay, now further it is connected with the circuit because we need some electricity over here. So we are going to connect it with battery, and then combine it with, now again we are going to use the same bimetallic strip over here. So bimetallic strip is over here like this. One strip is connected over here and the second one over here, and both are combined with each other like this. And finally, the second end of this circuit setup or this circuit will be connected on the other side. And we have a contact over here like this. So now if we talk about the components in the diagram, so this is our electric bell, and we are going to provide heat over here. Let's suppose we are going to work with fire alarm because we are making fire alarm. So it means whenever the temperature increase, or whenever we are experiencing with a fire, so it means the temperature or the heating effect we are going to observe in our atmosphere. And we have a contact over here. This is our contact. It works like a switch, right? because you observe that whole circuit is almost complete. Just there is a gap between contact and this bimetallic strip contact, right?
Yes.
So if this connection will be complete, so electric bell will start ringing, right? And how this connection or how these contacts combine with each other? If we provide thermal energy, and due to that thermal energy, these bimetallic strip will expand and they combine or they come into contact with the upper part of the circuit. So electric bell will start ringing, right?
Yes.
So this is a simple setup which is used for fire alarm setup in our daily life. So that can also be work on the principle of thermal expansion, right?
Sir, do we have to learn this?
You just need to remember, because if somewhere in MCQs in questions they ask you about it, so you just need to know about the concept of that what is bimetallic strip and how fire alarm will work on it. So you just need to remember about the basic concept. You don't need to know about the whole setup, because in previous papers or in old papers they ask you to draw the diagram or to complete the circuit, but now they don't ask about the detail diagram and the whole structure. If they ask about, so just they ask about 1 or 2 marks, just the basic concept, right? Let's suppose if they
Okay.
ask for 2 marks that explain the process that how this fire alarm or this electric bell will work if there is a fire in our surrounding. So you know that when fire or the heating effect we provide to bimetallic strip, so due to thermal expansion, bimetallic strip will expand and it will complete the circuit by contacting the upper part, and the electric bell start ringing. So questions may be some type like this. Okay.
Okay.
Okay, so we already know about the precautions, just like the distance between the railway tracks, and you also observe this same phenomena in the flyovers or in along bridges. So because also we are using steel rods in the construction of building or any flyover. So that's why we also kept gap in flyovers after some interval, because they also expand in high temperature. So that's why those are some precautions while we are working with thermal expansion, right?
Yes.
Any confusion?
No, it's clear.
Okay. So you may join back. Then we will continue with the other topic, that is the calculation based topic, which is known as the specific heat capacity, right?
Okay.